Welcome everybody, my name's Harley Smith. I'm going to be your teacher tonight, and we're going to be doing part one of a two-part series on plant nutrition. Tonight we're going to be looking at the essential elements, the minerals, the fertilizers that plants need to grow and reproduce. But next week we're going to follow up with a class on organic biostimulants, because plants need 17 essential elements to grow and reproduce, but there are biologically active molecules that aid with the uptake of minerals. So there's two parts of the story. There's the mineral nutrition, and then there's the organic biostimulants. But tonight, if you have questions during the class, go ahead and type them in. We'll have a question and answer session afterwards. And if you think of a question later, that's fine, just email me. That's my email address on the screen. That's my cell phone number too. If you want to call to discuss things, or you want to send me a text, that's fine. I'm here as a resource for you. So please go ahead and contact me if you have future questions after the class. Also, everybody that registers for tonight's class, I'm going to send them a link to the recorded version. So if you don't get everything the first time, don't worry about it. You can watch it over again and then send me a question if you have it. Or save it for next week when we continue with the series. Okay, let's go ahead and get started here. First of all, plants need 17 essential elements to grow and reproduce. 3 of them are free: carbon, hydrogen, and oxygen. They come from carbon dioxide and from water. Those 3 elements, carbon, hydrogen, and oxygen, account for over 95% of the plant's dry weight. So if all you're concerned with is increasing yield or increased production, do carbon dioxide supplementation. If you can increase the CO2 in your atmosphere to, say, 1,200 parts per million, you could see an increase in yield of 30 to even 50%. So carbon dioxide supplementation is great. Also, fresh air. And if you're not going to supplement and add more CO2, you need to have a source of fresh air to bring into your plants, because they'll deplete the CO2. If the CO2 is brought down to less than, say, 100 parts per million, the plants will stop growing. So fresh air is very important. You could have, the best nutrient solution in the world. You could have the most expensive organic biostimulants, perfectly tuned right to the specific needs of the strain of plants that you're growing. If you don't have the right environment, if you don't have the right amount of fresh air, and especially the amount of light that you need, the plants will not reach their genetic potential. So light is the limiting factor, especially for indoor growing. Plants need full spectrum light. They need the blue end of the spectrum and the red end of the spectrum. During the vegetative growth stage, plants prefer the blue end of the spectrum. They need full spectrum. They need all of the colors of the rainbow, but especially the blue, because plants have, over the years, have learned to compete for the light. If they're in the shade, they stretch to get above the other plants in the canopy, or they lean toward a break in the canopy. That's called phototropism, where a plant leans toward the light. But the plant isn't actually leaning toward the light. It's leaning toward blue at a very narrow wavelength. You see it here on the screen, right there at about the 460 nanometer wavelength. That's sky blue. So if you, during vegetative growth, you give the plant plenty of full spectrum light with the blue, enhanced blue at the 460 nanometer wavelength, the plants will be short and stocky. They'll have thicker stems. They'll have more dark green foliage, because blue is responsible for chlorophyll production more than any other color in the spectrum. And if the cuticle cells on the leaves will be thicker, so they'll be more disease resistant. And if you looked at the leaves under a microscope, the stomata, the pores that take in CO2 through the leaves, there'll be more of them, denser, closer together. So it turns the plant into a photosynthesis machine. So that is very important. That's why you invest in the expensive horticultural grow lights. If you brought in a standard, say, high pressure sodium lamp, a warehouse bulb, it's almost no blue. That'll be the worst light to use indoors, especially during vegetative growth, because there's no blue. The plants will be tall and spindly, not very good foliage, poor producers. But that's why most of the expensive horticultural grow lights, they're enhanced right there at the 460 nanometer wavelength to extend the spectrum. And in the future classes, we're going to do a whole class just on lighting, because that's the new frontier. In the Netherlands, they're experimenting now with light recipes, where they still use the HIDs for the primary light for photosynthesis, but then they're adding specific frequencies, like the blue end of the spectrum, that literally stimulates the plant to open up the stomata. Not only does it make more stomata, it opens them so the plant can take in the carbon dioxide. More of the canopy becomes photosynthetically active. A little bit of ultraviolet light is also beneficial, because if the plants are exposed to ultraviolet light, they start to make antioxidants to try to protect themselves from the UV spectrum. And they make pigments. Some of the pigments come out, and also some of the medicinal compounds that are important for us. So you can manipulate the spectrum of light as well as fine-tuning and spoon-feeding your plants with the right nutrients at the right time. Okay, during fruiting and flowering though, plants prefer the red end of the spectrum. Plants measure their age from dusk to dusk, from far red to far red. As the sun is setting, there's proportionally more reds. The sun goes down below the horizon, there's proportionally more far reds. And it puts the plant to sleep for the night. It actually turns off the active phytochromes in the plant. So if you can turn off the plants more quickly, you'll be able to wake them up earlier in the morning as well, so they can utilize the light more efficiently. If you don't give them a dose of the far red spectrum, they'll still shut down for the night. It'll take 2 or 3 hours for them to become inactive for their night cycle. Okay, so light's important. We'll talk about that more in future classes. But along with the carbon dioxide, plants need oxygen at the roots. They take in CO2 from the air. In the presence of chlorophyll, in full spectrum light, the red and blue end of the spectrum, they make sugars. And some of those sugars they use for energy to grow and reproduce. Some they store in the flowers and in the fruit. And some they leak from the roots to feed the plant growth promoting rhizobacteria and the mycorrhizal fungi. And we'll talk more about that later. But along with that though, they're during the day when the daylight's on, and they're storing energy from the light. They're storing it in the form of sugars. But day and night they're burning up that energy too, especially at night. In the middle of the night, that's when cell division is the strongest for the plants. So it's very important for the plants to receive that. But oxygen is necessary for respiration, and the most important place to provide the plant with oxygen is the roots for respiration. Dissolved oxygen in the root zone. So be careful, do not overwater your plants. If you overwater your plants, the pore spaces in the soil fill up with water, it suffocates the roots. And also if you overwater the plants, it sets up an anaerobic environment. The bad guys, the Pythium, Rhizoctonia, the root rots, are anaerobic fungi. They grow in stagnant water without oxygen. So be careful not to overwater your plants early on. When you water your plants, make sure there's a little water coming out the bottom of the pots, and then wait for them to dry out almost all the way before you water them again. Oxygen is very critical for respiration of the plants, to burn the stored energy. And there's another part to that too. I'll show you that tonight as well. One of the key themes in our classes is growing high Brix plants with a lot of stored energy. Brix is a measurement of the sugar content in the sap. If there's plenty of stored carbohydrates, then some of those carbohydrates are stored in the roots, and that can be used for energy during flowering later. So you want maximum yields, start from the very beginning by giving the plant very good nutrition to get more lateral root growth, more root mass, lots of stored sugars at the roots. And I'll show you some ways to do that tonight by spoon feeding your plants. Okay, the other essential elements besides carbon, hydrogen, and oxygen, are minerals, and they can be provided through organic fertilizers or through mineral fertilizers and hydroponics. Either way, plants need 17 essential elements, 14 minerals. If plants can't take up large organic molecules though, so if you're using organic nutrition, those large organic molecules have to be broken down by microorganisms in the soil, broken down into the form that the plant can take them up, into their what's called the ions. They're electrically charged particles. So whether you're doing mineral fertilizers or organic fertilizers, they have to be produced in water-soluble form that are immediately available to the plant. Okay, let's go ahead and take a look at some of the individual minerals, and I'll show you a strategy of growing tonight that I call spoon feeding, where we're giving the plant exactly what it needs when it needs it. Maximize quality, maximize yield, increase the plant's natural resistance to pest and disease. So let's go ahead and start with nitrogen. Now, nitrogen is the growth element. In the first half of a plant's growth, the plant's going to assimilate about 80% of the nitrogen it needs for the whole life of the plant. That's why most grow formulas are proportionally higher in nitrogen, because that's when the plant needs them the most. There's a balance though that plants need. Plants like either the nitrate form of nitrogen or the ammonium form of nitrogen. Those are the two forms of nitrogen that the plants can take up through the roots. Now, one of the biggest mistakes that beginners make is over-fertilizing, especially with nitrate nitrogen, the nitrate form. That's why I recommend for anyone out there that's using a mineral fertilizer, use half strength during vegetative growth stage, because it takes about 25 to 30% of the energy of photosynthesis just to assimilate the nitrates, whether the plant needs them or not. Nitrate nitrogen is a luxury element. The plant will take it up and burn its energy to do it. So if you overdo it with nitrate nitrogen, you get big top growth. They grow really fast. But you'll get big cells with thin cell walls, and they're going to burn up the energy of photosynthesis, and it will restrict the root growth. There'll be less carbohydrates to ship to the roots, and that will affect the flowering process later on. In fact, if you overdo it with nitrate nitrogen to toxic levels, like a lot of beginners do, it could delay or even prevent flowering. So bring your nitrate nitrogen down to adequate levels. Now, if the plant develops a nitrogen deficiency, then a little bit of the ammonium form of nitrogen is a quick fix. If you have a true nitrogen deficiency, just one dose of nitrogen, the plant will start to respond within 2 or 3 hours, and the symptoms will go away in a matter of a few days. Now, in hydroponics, the nitrogen is provided both as nitrate and ammonium. Usually about 90% of the nitrogen is in the nitrate form, and no more than about 10% is in the ammonium form. If you're doing organic nutrition, you're going to change that balance. You're going to have higher ammonium and less nitrates, because the microorganisms will change the ammonium form of nitrogen into nitrates. But it's a slow process, and it's a healthier process for the plant. So watch your nitrates, especially during the vegetative growth stage, because you'll actually lower the Brix and attract insects and make the plant more susceptible to powdery mildew and molds if you overdo it with nitrate nitrogen. So don't be fooled. Don't be fooled. Don't just try to grow the biggest plants you can. You want the strongest, healthiest plants with thick stems, a strong vascular system with lots of stored energy, because they can release that energy later on to produce vitamins, to produce antioxidants, to fight off insects, and also to have a burst of fruit and flowers during the fruiting and flowering stage. Okay, next we'll look at phosphorus. Now, phosphorus is the energy element. It energizes rooting, and it energizes flowering. When the plant takes in phosphorus, it is converted into a molecule called ATP. adenosine triphosphate. That is the energy currency of the plant. The plant will use energy to build phosphate bonds, and then when those phosphate bonds are cleaved, it releases the energy to grow and to reproduce. Now, one of the best times to use a little extra phosphorus, early rooting, because it energizes the rooting process for better root strike, better establishment of the plant. In fact, most commercial growers don't just have a grow and a bloom nutrient, they have a starter fertilizer that they use just for the first 2 or 3 weeks that's proportionally higher in phosphorus to achieve earlier rooting and a stronger plant. Because if you get stronger establishment of the plant, it's just going to transplant better. You won't have as much transplant shock. And if you have better root strike, the plant's going to be able to take up water and all of the other minerals more efficiently. So most commercial growers have a starter fertilizer that has a little bit extra monoammonium phosphate, because the ammonium form of nitrogen actually aids with the uptake of the phosphorus. I've done experiments in the lab where I've had just a very small amount of monoammonium phosphate to my starter fertilizer, less than a 1/16 of a teaspoon per gallon. And I saw 20% more roots at transplant. It's very obvious increase in rooting. So if you want to increase your root development early on, a little extra phosphorus. The other time to use a little extra phosphorus, early flowering. Phosphorus stimulates earlier flowering and more flowering sites. So it energizes the flowering process to get the flowering process going. Later on though, during the rest of the plant's growth, they still need phosphorus. They're going to need adequate phosphorus from day 1 all the way to the day of harvest, because they need it for making the energy molecules. But they're not going to need a lot of extra phosphorus at the end. In fact, during heavy fruiting and flowering, plants need more potassium. Potassium is the health element. It contributes to the quality of fruit and flowers more than any other element. During heavy fruit and flower production, plants can actually reduce or deplete potassium to deficient levels in 2 or 3 days. That quickly. And if you're pushing the plants, you're adding CO2, high light intensity, they deplete the potassium even faster. And if you're using BloomStimulants, which we'll talk about more next week, but if you're turning on the genes for more blooms and bigger blooms, it depletes the potassium even more quickly. So we want to put back in what the plant took out during heavy fruit and flower production by using a potassium supplement. Now you could use a PK boost, where you're adding phosphorus and potassium, but then you're adding extra phosphorus at the end when the plant doesn't need it. So my recommendation is add more phosphorus at the beginning of flowering and add more potassium during heavy fruiting and flowering and toward the end as a supplement. Now if you get a potassium deficiency, say you're growing tomatoes, you'll get watery fruit, be low sugar content, and poor shelf life. That's because potassium is a catalyst for carbohydrate metabolism to actually make the sugars. It activates enzymes that are used in photosynthesis, that are used in cellular metabolism as well to unlock them. Also, potassium activates enzymes that unlock the stored sugars in the roots and in the plant and ship them to the developing fruits and flowers. So even before you see symptoms of a potassium deficiency, the plants could develop what's called a hidden hunger. They just stall. And a lot of you have seen that, especially if you're growing in intensive gardening indoors. Everything's growing great. They're filling in with flowering sites. They're starting to set fruit. Then all of a sudden nothing seems to be happening. They're just not growing. It could be a potassium deficiency. Just give it a little potassium in the form of potassium sulfate would be a good one. It'll spark carbohydrate metabolism. The sugars flow to the flowers. They'll start to fill in again. You'll get better fruit and flower quality. Okay, next we will talk about the BloomStimulants. If you're using those, it depletes the potassium even faster. The pictures here, I did a trip to the Netherlands years ago, and I was able to do a side trip to Belgium where they're doing the first test on BloomStimulants. And for more blooms and bigger blooms. The plants that they were doing for control plants were sweet peppers. And even the control, without the bloom stimulant, 12 feet tall, loaded with peppers. In the next row, they were doing the bloom stimulant. And halfway through the trial, they were already at 10% increase in yield and rising. So it was very good. Now, the downside was they were also doing tests of the nutrient solution. And as the plant was putting on more weight with fruit and flowers, the plant was depleting the potassium faster than any other element. So if you're using bloom stimulants, then it's very important for you to use a potassium supplement with it so the plant can reach its true genetic potential. In fact, when I was in Belgium talking to the scientists, I said, well, why don't you put in some potassium then? So it's the same as the control. Otherwise, won't potassium become the limiting factor? And they said, we can't do that. I said, why not? They said, because in a controlled experiment, you can only have one variable. If you were to add the potassium, someone could read the report later on and say, oh, the reason you got more yield is because you added more potassium instead of the bloom stimulants themselves. But I can tell you this, if you're using a bloom stimulant, if you're pushing your plants, it's very important for quality to keep the potassium to nitrate ratio high. As the plants are drawing down the potassium, we put it back in so we can get the best of the best of quality. I'll talk to you next week. We'll talk more about the bloom stimulants. I'll show you how it actually works. It actually activates the series of genes that tells the plant, don't make more stems and leaves, make flowering parts. But come back next week and I'll show you about bloom stimulants and how those are being used around the world to increase quality and yield. Okay, let's move on to the other essential elements. Okay, we know plants need nitrogen. That's why most of the vegetative growth formulas higher in nitrogen. The bloom formulas will be higher in phosphorus and potassium. We want to keep an eye on our potassium to nitrate ratio. On your bottles of fertilizer, you'll see the three numbers that stand for N, P, and K, nitrogen, phosphorus, and potassium. And what we want to see during the vegetative growth stage, especially in hydroponics, where you have very good control at the root zone, is about 1.5 times more potassium than nitrogen. But during the fruiting and flowering stage, you want to reduce the nitrate nitrogen a little more, but increase the potassium. So it's about a 2-to-1 potassium to nitrogen ratio, or even more. Also, we want to make sure that we don't overdo it. Like I said, you overdo it with nitrogen, you can delay or prevent flowering. You'll get big plants, it'll be big cells with thin cell walls, it'll attract insects, it'll attract fungus. Also, you'll have lots of dark green foliage, but it'll be rank growth. It'll be soft growth and not healthy growth. If you overdo it with phosphorus, phosphorus toxicity shows up as a zinc deficiency. Zinc deficiency first, iron deficiency second, and magnesium deficiency third, in that order. So, especially if you have hard water and you're using a lot of phosphoric acid to lower your pH, in hydroponics, we want to make sure that we use a hard water nutrient, because the hard water nutrients have more nitric acid in them and they're a little more acidic, so we don't overdo it with the phosphorus. I have hard water, so I never use phosphorus supplements because I'm adding so much phosphoric acid to lower my pH. And that phosphoric acid is actually a fertilizer for the plant. The plant will take it up. So toward the end, I'm very careful with the amount of phosphorus I add. Don't add too much, but I add my potassium along with it. Now, calcium is the next essential element. In fact, plants take up more calcium than they take up phosphorus. Calcium, to me, calcium is king. If you want to grow the best of the best of quality, we need that high potassium for carbohydrate metabolism, but we need a strong vascular system. And calcium is a passive element. It's only taken up in the transpiration stream. So if you have high humidity you can get a calcium deficiency, even if there's plenty of calcium at the root zone. So we want to watch our relative humidity. We're going to keep it between about 40 and 60%. If it gets too high, you'll get a calcium deficiency. It shows up as blossom end rot in tomatoes. It shows up as tip burn in lettuce. And it shows up in the new growth, in the bud development at the top of the plant, deformed growth. So we need to get it into the plant, not just have the right amount at the root zone. So humidity first. The second thing, good air movement. We want to have oscillating fans indoors so that all the leaves are gently moving. Because during photosynthesis, the plants are taking up water in the photosynthesis, but they're also transpiring water through the leaves. So if you don't have good air movement, the plants develop a vapor barrier on the bottom side of the leaves with that stagnant air. And then the plants can't take in carbon dioxide, and they can go into photorespiration, very inefficient use of the light. And also if they have a vapor barrier, they're not going to be able to take up enough calcium. You'll get a calcium deficiency. And I think that part of the problem when you have high humidity and you have fungus is because you don't have enough calcium. And I'll talk more about the biostimulants next week, but if you can get more calcium into the plant, calcium ions react with pectic acid in the plant to make calcium pectin. That's the glue that glues the cell walls together. So if a mold spore lands on a leaf like powdery mildew, it wants to get to the water in the interstitial space. And then it germinates, it becomes systemic and spreads. But if you get lots of calcium uptake, instead of water in the interstitial space, you have pectin, calcium pectate. So by the time the mold spore germinates and is able to penetrate the cells, it dries up and dies. So we can prevent powdery mildew if we can increase the uptake of calcium. And I'll show you some more ways to do that next week by using amino acids along with your nutrients. But today though, calcium is really important. Also, calcium gets locked up in the soil very easily. It locks up with phosphates to make calcium phosphate. That's what your bones are made out of. 95% insoluble. That means it's unavailable to the plant if it reacts. It locks up with sulfates to make calcium sulfate. That's gypsum, plaster of Paris. 98% insoluble and unavailable to the plant. So we need to have water-soluble calcium. That's why in hydroponics you'll see a 2-part nutrient, or even a 3. All the calcium is in one of the parts, and all the phosphates and sulfates are in the other part in concentrated form. Otherwise they'll react and form limescale and become unavailable. But in dilute form, they're available to the plant. So when we come back next week though, I'm going to show you how nature solves the problem of calcium deficiency. Not only to chelate the calcium and keep it soluble, but to open up calcium ion channels in the roots so the plants take up calcium 1,000 times faster than simple osmosis. Okay, next let's look at magnesium. Magnesium is the central element of chlorophyll. And it's actually the magnesium that makes plants green. Now, unlike calcium though, magnesium is a mobile element. It can be, once it's locked up in the leaves, if there's a magnesium deficiency, plants can take magnesium from the bottom leaves and send it to the top leaves where it's needed the most. It can't do that with calcium. Calcium is an immobile element. Once it's assimilated by the plant, it's locked up. It's like cement. It can't be transported to the new growth. That's why you see a calcium deficiency at the top of the plant. Where a magnesium deficiency, it'll show up first in the bottom leaves as intervenochlorosis. The veins of the leaves will stay green, but the tissue between starts to turn yellow. So magnesium is very important. Now, if you overdo it with potassium, you get a potassium toxicity. It shows up as a magnesium deficiency. I'll say that again. A potassium toxicity, if you overdo it more than the plants need, shows up as a magnesium deficiency. So if you see that forming during heavy flowering and you're using a PK boost or a potassium supplement, then back off on the potassium. But it's really easy to fix a magnesium deficiency though. You just add a little magnesium sulfate, little Epsom salts. You can even spray it on the bottom leaves. The plants will green up in a matter of days. Magnesium also works along with potassium. Magnesium activates the enzymes that are responsible for what's called phloem loading, where the sugars are loaded into the phloem so that they're shipped to the fruit. That's why when the energy needs of the plants are the highest, a lot of times you'll see a magnesium deficiency. Also, magnesium activates the enzymes that hold the ATP molecule, the one that contains phosphorus, that hold the molecule in position so those phosphate bonds can be cleaved to release energy to grow and reproduce. So again, when there's during the transition from grow to bloom, or during fast, heavy, vigorous vegetative growth or heavy flowering, that's when you're going to see the magnesium deficiency. So when I add my potassium supplements during flowering, I like to add a little magnesium with it because they balance each other. They helps prevent a magnesium deficiency, and it helps the sugars flow to the flowers and the fruit to bulk up all the way to the end. Okay, next is sulfur. Sulfur is responsible for the aroma of flowers, and it also is part of the flowering process. When a plant assimilates sulfur as sulfates, it actually assimilates them in the chloroplast, the same place, the green, where it's storing the chlorophyll, where the nitrate nitrogen is assimilated in the chlorophyll, in the chloroplast because of the high energy needs. So are the sulfates. And when the plants take in sulfates, the sulfates are changed into an amino acid called cysteine. 4 cysteine molecules attach to one zinc ion and form what's called a zinc finger transcription factor. It actually goes into the cell, into the DNA, attaches to the DNA, and turns on a series of genes that tells the plant, don't make more stems and leaves, make flowering parts. So years ago, 20 years ago, when I started out in the hydroponics industry, one of my very first experiments was to create nutrient formulas that were missing one element only, so that I could create the nutrient deficiency and see what it looked like in the plant. Now the sulfur deficiency was very interesting back then. It didn't show up very dramatically during vegetative growth stage, the zero sulfur. You know, it was about the same height. When the leaves were smaller, they weren't as dark green, didn't look as healthy, but no significant difference. But during the flowering stage, the control group that had the sulfate, 12 to 14 inch flowers loaded with petals. The one with no sulfate, 2 inch flowers, just a few little sparse petals. So I knew even back then, even before scientists discovered the zinc finger transcription factor, that sulfur was a part of the flowering process and didn't just contribute to aromas and flavors. So, but we don't have to add a lot of extra sulfur because the sulfate, if you're adding potassium as a supplement, it's usually as potassium sulfate. So it has potassium and sulfur. If you're adding magnesium with it, usually in the form of magnesium sulfate. In fact, in hydroponics, you add magnesium sulfate for your magnesium source, it has 5 times more sulfur than the plant needs. But again, during the flowering process, that little extra magnesium sulfate can contribute to the process. It can help the plant bulk up all the way to the end. If you look at a lot of the sweet products out there that have the sugars in them, the carbohydrates, they're loaded with magnesium sulfate. And I think, personally, I think that it's the magnesium sulfate, the sulfur, that's doing more for bulking up than the sugars are themselves. In soil, though, then you want to feed the microbes, and they'll feed the plant. Okay, so sulfur is important during flowering. Okay, the trace elements. I'm taking a look at my time here. Looks pretty good still. Better move on a bit though. Iron, manganese, copper, and zinc, those are transition metals. They actually activate enzymes in the plant that are responsible for cellular metabolism. It's part of the electron transport train for photosynthesis. They conduct electricity in the plant that the plant can use to do other chemical reactions. So even a small amount of those trace elements, we don't need much, but they turn on enzymes. And if an enzyme is turned on, one enzyme could do as many as 1,000 chemical reactions per second inside the cell. So even though we only need small amounts, they're essential elements, especially iron, because iron is a catalyst for the production of chlorophyll, the green pigment. And it's also very important to activate enzymes that make the medicinal compounds and plant protection agents. When the plant's under stress, we'll talk about next week in our biostimulant class, they make an enzyme that's a plant protection agent. It protects the plant against heat stress and drought stress, salt stress, UV stress from the lights. But that enzyme has to be turned on. It has to be turned on by either an iron-manganese complex or a copper-zinc complex. So making those trace elements available to the plant is important. And the way we do it, and especially in hydroponics, is provide those metals in their chelated form. Chela means claw. So a chelate is an organic molecule that attaches to an ion like a claw. It holds it tightly enough so it doesn't react, but loosely enough so it's available to the plant on demand. Okay, so those trace elements are very important, and with them, watch your pH. It's critical. In hydroponics, if the pH gets above 6.5, which is barely acidic, iron deficiency will happen very quickly. If it gets above 7.5, all the trace metals, iron, copper, manganese, zinc, we can put them in there. They're unavailable to the plant. Other trace elements, boron, that aids with sugar transport, chloride, that's important for keeping the plant turgid. It's also helps with photosynthesis. Not chlorine, that's different. The chlorine gas is an oxidizer. It's used to kill microorganisms in the water. If you can smell the chlorine in the water, there's too much chloride, because it can actually burn the cell membranes in the roots and hurt the plant. But chloride itself, the plant needs that as an essential element. It's rarely added though, because there's chloride in the soil, there's chloride just as contaminants in your fertilizers. Molybdenum, very, very small part of a trace part per million, but it works too in nitrogen metabolism. In Australia, the soils are low in molybdenum, and they used to be a wheat importing nation. But once they realized the soil needed molybdenum, they started adding just a small trace amount to the fertilizers. They went from being a wheat importing nation to being a wheat exporting nation. So even though it's a trace mineral, even though it's only used in a fraction of a part per million, it's still an essential element. And without it, the plant won't be able to not only reach its genetic potential, but it won't even be able to live and reproduce. Nickel, that's another trace element that activates an enzyme that makes urea available to the plant, again used in small amounts. In fact, when I started out in hydroponics, nickel wasn't even considered an essential element. But now that we have better ways of creating more pure fertilizers for the roots, scientists were able to discover that nickel is important as well. So the best fertilizers, the very best of the best, especially in hydroponics, will include just a little bit of nickel as well. Okay, let's move on to silica. We'll talk about that more next week, but that's a beneficial element. It works along with calcium to strengthen the stems and leaves, and also helps strengthen the plant against fungus and powdery mildew. We'll talk about that more later. Okay, let's do a quick diagnosis here, quick rundown. A little bit of a summary too. Yellow leaves. Today, someone brought in a baggie of leaves to me that were yellow. I said, what's wrong? Why are my leaves turning yellow? There's a lot of things that can contribute to that. I wrote a whole article on it in Maximum Yield. If you go through the archives in March of 2014, go ahead and look that up. You can read more about that and help you diagnose it. But really, when it comes to mineral deficiencies, it's one of three. It could be a nitrogen deficiency. If it is, there'll be a general yellowing of the plant. The leaves will turn pale yellow, starting at the bottom of the plant and working its way up. With just one little dose of nitrogen, the plant will respond. It'll recover in a matter of days. Next is magnesium. Remember, that's the central element of chlorophyll. That will show up as interveinal chlorosis, yellowing, starting at the bottom of the plant. The veins stay green, the tissues turns yellow. One little dose of magnesium, though, is magnesium sulfate, either as a foliar spray or at the roots or as CalMag, but that has nitrates, so don't spray that on the leaves. But you can use it at the roots, plants will green up. The other is iron. Now, iron is immobile, just like the calcium, so those symptoms will show up at the top of the plant, because iron is a catalyst for chlorophyll production to make the green pigment. So you'll see that at the top, and most of the other trace metals like the manganese and the copper, that shows up first in the top leaves as well. But if you can provide some kind of a chelated trace elements, that deficiency goes away very quickly. And we'll talk more about this next week, so I don't want to spoil it for next week when you come back. But in nature, humic and fulvic acid as a biostimulant actually aid with the uptake of iron and other minerals, especially the trace elements. Humic acid and fulvic acid stimulates an enzyme in the cell membranes called H plus ATPase. So it's a proton pump. The outside of the cell membrane becomes more positively charged. The inside becomes more negatively charged. The voltage potential goes up across the cell membranes. The plant's able to take up iron more efficiently. Also, as the plant pumps the protons, the outside of the cell membranes become more acidic. So it solubilizes those trace elements. The surface of the roots could be as much as 3 points lower in pH than the surrounding soil. So humic and fulvic acid, excellent way to treat trace mineral deficiencies. Plus they have over 62 beneficial trace elements from ancient compost piles. If you're using RO water, I don't know if you are, but if you are, you're stripping all the minerals out of the water, all the bicarbonates, including the trace elements that the plants need. So if you're using RO water, add a little humic or fulvic acid first. It helps buffer pH. It raises the pH of acid soil, lowers the pH of alkaline soil. It helps buffer changes in pH in your hydroponics if you're using RO water, and it's providing a lot of trace elements that the plants need. Also, you can use fulvic acid as a foliar feed. So if you're seeing a iron deficiency, just spray a little bit on the leaves. The fulvic acid will transport the iron through the cell membranes, release it inside the cells where the plant needs it the most. But come back next week and we'll talk more about it.